All right, guys, now that we have our review of immunity all done, we get to look at what some of these microbes do, some of these bacteria in particular, to get around all of those in one way, shape, or form. There are lots of organisms out there that cause disease, and it's despite the fact that these immune protections are there, right? So we're looking at what is called microbial pathogenicity. Okay, pathogenicity is the ability to cause disease. Okay, if you hear the word virulence, well, that's more the level of pathogenicity, right? What is the level of an organism's ability? So pathogenicity, we're looking at those mechanisms. Chapter 15 is where you're going to find a lot of this stuff. And the first thing that I'd like you to know about would be what makes sense, that it would be the first step, and that is a microbe that's going to cause disease has to attach to you first, right? It has to adhere somehow. And many organisms have what is called nonspecific adherence, the ability to bind, sounds like, in a nonspecific way, and that's exactly what it is. And we already know about capsules, slime layers, stuff like that. Those would be forms of nonspecific adherence, ways that bacteria can bind to smooth surfaces without a lot of proteins to attach to. And so this would be a perfect example, like on your teeth. There could be natural surfaces like that, or they could be man-made surfaces, glass, plastic. These nonspecific adherence mechanisms are what are used by organisms that form biofilms. The communication among organisms on these kinds of surfaces is pretty amazing, especially with biofilms. This shows you kind of an evolution of what a population of bacteria will do when they're in a biofilm form. They will bind and attach, for example, to catheter surfaces, for example, like a Foley catheter, and they will grow, of course, and proliferate. But they are also communicating with one another in very sophisticated ways that we didn't realize for a long time. And they're kind of out competing one another in a region if there's too many cells. So they're actually communicating, and ultimately chemically they are cued to release and actually detach and colonize other spots. All right. A classic example of an organism that does that is Pseudomonas. So here we have a picture of Pseudomonas growing on a flat surface. A guy, getting his name right now, but there's a whole team of people that work over at BU, and they work with Pseudomonas, and they've got all sorts of tubes that they work with where the Pseudomonas is growing inside those tubes. And what these organisms can do is something called quorum sensing. Now, that sounds like really sophisticated and everything. Quorum sensing, a really hard word, but basically what quorum sensing does is it allows for chemical communication, right? So we have chemical communication in our bodies all the time, right? You can just think about hormones and other chemicals that bind chemoreceptors, and we respond to those changes, right? Well, so don't these populations. They respond to these changes as well. We're going to see biofilms. You're going to see them on dentist instruments if they're not sterilized properly. You're going to find them on catheters. Okay, that's why you need to change catheters every day or two, something like that, right? Contact lenses, right? Any of these places are possible places we find them. We also find biofilms in the throat and other natural areas. So it's not like all biofilms are bad, though obviously that toilet looks pretty bad, right? I always tell students that was my toilet this morning before I went to the bathroom, and it's not really. All right, here's some pretty other, I should have warned you, there in this section there's some kind of, I could be upsetting images, but these are real images of places we have biofilms. Staph aureus makes biofilms and causes major problems, like you see down here for diabetic patients with poor circulation. This is where these bacteria can get the best of someone. Even yeast can cause biofilms on catheters like you see here. All right, so we have nonspecific adherence, stuff to do with capsules and slime layers and stuff like that, but we also have specific adherence. So here we see a microbe, some bacterium, and it's got certain proteins. They're calling them adhesins. Perfect name, right? An adhesin probably adheres to something, and it does indeed. It specializes for sticking to certain proteins, certain molecules on certain cells. All right, it's that picky. So you're going to find that some bacteria can bind really well in some places in the body or on the body, and not very well at all in others. We're going to see specialized adhesins. For example, E. coli has particular proteins on its surface that allow it to grab on and hold tight to bladder cells. They can cause those urinary tract infections, right? Bacteria that live on our skin, even especially the natural ones, the ones that grow there in our normal flora. How do they stick? Some of them stick through specific adherence. They have specific ways to attach to specific proteins and receptors that exist there. A couple of extra ones. So we talked about how it was that in the mouth you could have non-specific adherence. Well, so happens there's also specific adherence with Streptococcus mutans. This is one organism that causes dental caries, and it grabs on real well to certain proteins in the oral cavity. Let's see, do we have more? We do. We have Treponema Pallidum. So this is the organism that causes syphilis, and it naturally binds through specific adherence to the mucosa of the mouth. Here we have some pretty nasty ones. These are some very inflamed underside of eyelids, and the conjunctiva happens to be the layer there, you may remember from A&P. And conjunctivitis is certainly what's going on here, but a really severe form. And chlamydia does that. We talked about how a lot of times eye ointments will be used, antibiotic eye ointments, to avoid blindness for children that are born of mothers that have some of these STIs. Gonorrhea can cause this as well. All right, another way that organisms can attach is through fimbriae and pili. We already kind of touched on this, but I wanted to mention it again here now that we're talking about the pathogenicity of bacteria. So what we'll find on a lot of fimbriae and pili is that they actually have proteins on them as well. And those proteins also allow for attachment. So it's not just on the surface of the envelope, on the membrane or the cell wall that you find these. You also find them on these long, thin fimbriae, like you see here from the E. coli that causes major diarrhea and horrible toxigenic effects in the intestines. And same is true with whooping cough, with pertussis. It grabs hold in the throat, and you can see some of the cilia here, and this is kind of hard to see, but you can also see they're pointing at bacteria. Here's one, right? These are all Bordella pertussis that cause whooping cough. So these are all bacteria here, and they're grabbing tight using fimbriae and pili. Okay, so we'll leave it there, and we'll continue talking about some of the other ways that bacteria actually kind of hide themselves from the immune system next time.